In this video, we're going to cover ratios and areas of polygons. I really like this problem because it takes quite a few concepts to be able to solve it. So here's the problem. A 6-inch by 14-inch rectangle contains a hexagon and 4 congruent isosceles triangles. Point A and point B are midpoints of the smaller sides of the rectangle. What is the ratio of the area of the hexagon to the combined area of the triangles? And so at this point, you can either stop the video and try to solve it on your own, or you can keep going and we'll get right to the solution. So the first thing to understand about this problem is that point A and point B are midpoints. So they split the smaller sides in half. So if you take half of 6, that's going to give you 3 and 3. Now, the other thing they also said is that all the triangles are congruent, which means they're all the same size, and that all these triangles are isosceles. That means that 2 of the sides are congruent on each triangle. So if one side of the triangle is 3, that means the other side of the triangle are also 3. So essentially, you've got 4 triangles, and they all have a base and height of 3. So the first thing we're going to do is we're going to find the area of all the triangles. And so obviously, we need to find the area of one of the triangles first. And so we have a triangle. Each of these triangles has a base of 3 and a height of 3. And the area of a triangle is 1/2 base times height. And so that's going to be 1/2 times 3 times 3. And that's going to give us 4.5 square inches. So now that we know the area of one of the triangles, now we can get the area of all 4 triangles since they're all congruent. And so the total area is just going to be 4.5, which is the area of one of the triangles, times 4. And that's going to give you 18 square inches. So now we know the combined area of the triangles is 18 square inches. Now we need to get the area of the hexagon. And in this visual, you can kind of see how we're going to plan and get this area. So the hexagon can be found by finding the area of the entire rectangle, subtracting off the triangles, and once you subtract off the triangles, the hexagon will be left over. So that's what we will do next. So let's go ahead and find the area of this rectangle. So the area of a rectangle is length times width, or base times height, whatever one you're used to. And so that's going to be 14 times 6, which is 84. So the area of the rectangle is 84. In the previous step, we found out that the combined area of the 4 triangles was 18. So now at this point, all we need to do is subtract the 2 answers. And 84 minus 18 should give you 66. So the area of the hexagon is 66 square inches. So now let's finish up by getting the ratio of the areas. Now, since they're asking for the ratio of the hexagon to the triangles, you have to give it in that exact same order. So the hexagon has an area of 66. The combined area of the triangles is 18. So therefore, the ratio is 66 to 18. So even though that's the correct answer, it's not part of your answer choices, which probably means your ratio can be reduced. So I'm going to go ahead and write this ratio as a fraction, and I'm going to reduce it. 66 and 18 are both divisible by 6. And so reducing that, you're going to end up with 11 over 3. Changing its form, that's the equivalent of 11 to 3. So it looks like the ratio of the area of the hexagon to the combined area of the triangles is 11:3, and that means the answer is A. Feel free to visit the site mathonthefly.com. We have over 100 ACT math worksheets that covers a variety of topics. And also take a look at our ACT math book that's available in paperback form on Amazon. And you can also on the website get the book in PDF form. It has over 1,100 problems with complete solutions, and it's a good guide and get good practice for the exam. Also, sign up for our mailing list, which gives us updates and other stuff that's going around with the site as well. With that being said, hopefully you liked the video, and I'll see you in the next video.